We're going to take a closer look at the trigonometric graph that represents the average amount of daylight in Ottawa and try to interpret its key features and how they relate to the context that we're looking at. First of all, the domain. The domain is x is less than or equal to 10 but greater than or equal to 0. It represents the time frame that we're looking at in this problem. The range. Y is less than or equal to 930 but greater than or equal to 523. The average amount of daylight must be between, for all the months, must be between our maximum in June, which is 930, and our minimum in December, which is 523. We don't have any x-intercepts. We don't have any months, and we're assuming we don't have any months that have zero amount of minutes of daylight. The y-intercept, we're guessing, is close to 540. This is the amount of daylight that we would have at the beginning of the 10-year cycle in January. It must be greater than the minimum of 523, so we're guessing that it's maybe 540. But we really don't know because we don't actually have that data. The maximum value is, of course, 930, the amount of daylight in June, and the minimum is 523 minutes. The period. The period is 1. This is the amount of time it takes for us to see a cycle completed. This makes sense because the cycle repeats every calendar year. The amplitude. The amplitude is the difference between the maximum and minimum values divided by 2. In this case, it works out to be 203.5.